In this lesson, we're going to move away from pathfinding algorithms and start delving a bit more deeply into how artificial intelligence works and what the differences between different types of AI are. We're also going to develop an understanding of deep learning systems, machine learning systems, and reinforcement learning systems, and the reasons for using these methods. So as usual, let's begin with some key terms. Now, some of the key terms that you see on screen might be known to you. Others you might have encountered for the very first time, but it's essential for you to understand what these terms actually mean. So do pause the video and jot these down. Machine learning basically implies systems that learn without being programmed to learn. Deep learning, on the other hand, is basically when machines think in a way similar to the human brain. They handle huge amounts of data and use artificial neural networks. Labeled data is data where we know the target answer and the data object is fully recognized by the machine itself. Unlabeled data, on the other hand, is data where objects are undefined and need to be manually recognized by a human. Supervised learning is a system which is able to predict future outcomes based on past data, and it requires both input and output values to be used in the training process. Unsupervised learning, on the other hand, is a system which is capable of identifying hidden patterns from input data. The system is not trained on the right answer. And this one is very useful when you create systems which are based on reinforcement learning. Systems which are given no training whatsoever and they learn on the basis of reward and punishment. Semi-supervised or active learning. These are systems that interactively query data sources to reach a desired result. It uses both labeled and unlabeled data, but mainly unlabeled data on cost grounds. Reward and punishment, we mentioned that a moment ago, is the improvements to a model based on whether feedback is positive or negative. So actions are optimized to receive an increase in positive feedback. Okay, that's enough about the key terms. Let's begin looking into AI in a bit more depth. Now, AI is the overall area which is the use of intelligent machines that think and behave like humans. When we talk about machines, we talk about a combination of hardware and software, but they can be either or both of them. Now, within AI, there's a subset which is called machine learning, and these are systems which learn without being programmed to learn. And within that, there are systems which are called deep learning systems, which are machines or software that think in a way that's similar to the human brain. And these can handle huge amounts of data using artificial neural networks. So think about self-driving cars, think about the decision-making processes that banks employ to grant or refuse loans, that kind of level of depth. However, for most people, the example of an AI will be something like a voice assistant like Amazon Echo or Google Home or Siri. And the user will normally ask a question in natural language. Hey, what's the temperature in a particular town, for example? And this will be then broken down into binary. A server will process it, analyze it, and then prepare a response. And that response will then be converted into voice, and that voice will then be output by the speaker. Now, you probably have used AI like this quite often, and we don't really think about how it actually works. We just know that we can ask a question and we get a response. Even that isn't really true artificial intelligence, because all you're doing is just a simple query. You're just looking at a way of deciphering what the person is saying and then working out what the key terms are, conducting a search and formulating a response, which links to machine learning. Now, you do something like this quite often as well. You type a search in Google, we all do this, and then you get a list of results. You select one of the first few links and then you spend some time there. Now, when you do that, Google's algorithm rewards itself and says, well, okay, I understand what the user wanted and they got what was required. If, for example, you scroll down the page and then you go to page 2, 3, and you don't spend much time on any of the links, it punishes itself by simply saying that, well, the user didn't get what they wanted, therefore they were looking at other links. So perhaps I need to tweak my algorithm slightly. And the machine is doing this automatically all the time. It's learning on its own. And the final one is deep learning, which is all to do with perhaps if you ever use one of those beautification apps or you ever converted a black and white image to a color image, you probably are using some kind of deep learning model. So how does it all work? In the case on screen, a black and white image is passed through a CNN or a convolutional neural network, which has a lot of hidden layers. And at each stage, the image is broken down into pixels. Then the pixels are reconstructed into various different shapes. One layer might detect the edges, then another layer might detect faces, another might detect objects. And as you go through these layers, you build a picture of what the original image was constructed of. And then you query perhaps existing images of, say, beach balls and human faces. And then from that data, you start coloring that, okay, most beach balls look kind of like this, so I'm going to start coloring this beach ball like this. Most humans look like this, and then I'm going to start coloring their faces like that. Deep learning systems significantly depend on the data that they're fed, and this is where the bias can kind of creep in. If you only give it pictures of, say, red and cream beach balls, then it's going to paint every single beach ball the same type of colors. So let's look at AI in a bit more detail. So we define AI as a machine with cognitive abilities such as problem solving and learning from examples. And we measure against human benchmarks such as reasoning, speech, and sight. There are three categories that we measure artificial intelligence in. The first one is narrow AI, which is superior performance to a human on a simple task. For example, a Go or chess program. That's very focused in one particular area, and it can beat humans in that particular domain. The next one is general AI, and that's similar performance to a human in an intellectual task. For example, essay writing, making art or music, that's general purpose AI. But again, it's one particular task. The one that we actually get scared about is strong AI, and that's superior performance to a human in many tasks. And this is where your Skynet, this is where all of those stories that you read in science fiction come from. We're nowhere near developing an AI that is strong at this particular point in time. There is that talk about singularity, the time when you will have a strong AI emerging in about 2040 or 2050. It could be sooner. However, we're not at that particular level just yet. And if you equate the current examples like smart home devices, intelligent news feeds, weather forecasting systems, even text to art or text to music generators, we're still in the domain of general AI. Now, I would like you to maybe pause for about 10 minutes and do some research of AI use in the following areas. Research how AI can be used for knowledge representation, automated reasoning, computer vision, and robotics. You don't really need to go into a lot of depth, but you've got to be aware that AI is being utilized in these particular areas and beyond. Now, in an exam, you'll probably be asked, what are the areas that AI is being utilized in? And you won't go wrong by just talking about knowledge representation, automated reasoning, computer vision, or robotics. There are lots of videos on YouTube that you could follow to learn a lot more about this. So do take a short break and learn about these before continuing. Okay, let's move on to machine learning now. Machine learning is a subset of artificial intelligence. Algorithms are trained and learn from past experiences and examples. So the system can make predictions or take decisions based on previous scenarios. Now, this leads to fast and accurate outcomes depending on the processing capabilities of your computer system. Machine learning systems can analyze huge volumes of quite complex data that can take a lot of human years using traditional means. And it uses both labeled and unlabeled data. So the labeled data is data which is recognized by the system. Unlabeled is unidentified data and needs to be recognized. When you get a question related to machine learning, you need to make sure that you can answer at least 4 or 5 of these points. What does all of that mean? Let's look at an example of machine learning. So on the left-hand side, we've got pictures of birds, which are known as labeled data. We've identified these birds, we can label them as whatever they are. So the model is trained based on the features of these birds. The model learns and starts comparing bird features. Then we introduce new data, for example, the new bird that's been detected. And then using that new data, we get an output which then classifies how many birds were from each category based on what we've labeled earlier. Algorithms are used to analyze incoming data by comparing it to the labeled data, for example, bird features, and then categorizing any new data that's fed into the system. This way, informed decisions are made based on prior learning. If it didn't introduce the labeled data, then the system wouldn't have a clue about what to do. So how do we get the machines to learn? Well, we can use 4 different approaches. The first one is called supervised learning. And this particular approach involves regression analysis, where variables have an impact, and classification analysis, where data mining is used for predictions. We'll look at regression analysis and classification in a bit more depth later on. So supervised learning involves regression and classification. This allows us to predict future outcomes based on past data. Think about weather forecasting systems, stock forecasting systems. They're all part of this category of supervised learning. This type of system has to be fed input and correct outputs to learn. So it uses a lot of label data. It is then tested using label data to confirm that it's indeed giving you the right output. Once we have enough confidence in the system, we then test it with unlabeled data to predict outcomes. However, if an error occurs, at this particular stage, the model is refined further until we get the perfect outcome. An example of this type of system is something that you use every day without realizing it. It's categorizing email spam without human intervention. The next model we're going to look at is the unsupervised learning model. Here, you identify hidden patterns from input data. The system is not trained for the right answer because we might not know what the right answer is. This requires a lot of data organization. You use density estimation and k-mean clustering. In simple terms, basically the classification of unlabeled data. You don't need to know what these means in mathematic terms. You just need to know that density estimation and k-mean clustering allows you to classify unlabeled data, and we use that with the algorithms of unsupervised learning. These algorithms then evaluate the data and identify patterns. An example of this type of system is identifying groups of individuals with similar purchasing behavior, which is normally what e-commerce sites use it for. The next model, semi-supervised learning, makes use of both labeled and unlabeled data to train algorithms. And these type of systems can interactively query the source data and produce whatever the desired output is. Unlabeled data is used a lot in this type of system because labeled data is the correct way of doing things, but labeled data requires a lot of human intervention. We've got to spend money labeling the data and categorizing it, and it's expensive business. So if we can use unlabeled data as much as possible, that keeps the costs low. Now, a small amount of labeled data is combined with this huge amount of unlabeled data because the small amount of labeled data is where your categorization happens. Once you're happy with the categorization, you then apply it to the unlabeled data. And examples of this includes web crawler systems that index web pages online. So you say, well, okay, this is how you go about indexing web pages. Now, here's the entire unlabeled internet. Go to every single website and then start categorizing it or labeling it. That's how Google Search's algorithm works. The final model is called reinforcement learning. And here the system is not trained. It learns on the basis of reward and punishment, basically trial and error. For example, you can allocate points to the system for every single time it gets to a correct outcome, and you can deduct points for every single time you get an incorrect outcome. This helps train the system, and it also increases the efficiency of the particular system in making use of optimization techniques. It gets greater confidence in its own ability to come to the correct conclusion. And examples of this include search engines, robotics, and online games. So every single time a system gets the correct output, it knows it's got that confidence that, yes, I've got the right answer. It doesn't tweak its algorithm. It just thinks, well, okay, brilliant. Every time it doesn't hit the mark, it readjusts the way it calculated the answer and then checks again. And it'll keep doing it until it gets the most optimum output every single time. Okay, that's all for today. Hopefully you understand the difference between narrow, general, and strong AI, and you can explain what is meant by an artificial neural network. a system that's modeled on the human brain. What are the 4 types of machine learning models, and what are the differences between these 4 types of machine learning models? Which ones use labeled data? Which ones use unlabeled data? Which ones use a combination of both? Which ones use reward and punishment? If you do have any questions about this particular section, do get back to me. Otherwise, I'll see you in the next one.